This is the unit circle. Unit circle means the radius is 1. The circumference we know is 2 pi r. 2 pi times 1 is 2 pi. Circle here, we are looking at this angle, which is pi over 6. We get this nice little right-angled triangle. Pi over 6 is 30 degrees. This angle is 30 degrees. We double that angle, we end up with a nice equilateral triangle, right? So if this is 30 and this is 90, then this is 60. If I double this angle, this becomes 60. This angle is 60. This angle is 60. That makes this an equilateral triangle. And we know the radius is 1 because it's the unit circle. If the radius is 1, then that means this height from here to here is half of this, which is also 1, right? So this is going to be a half. If that's a half, we just have to find this length here. So I'm going to use Pythagoras' theorem. B squared is equal to C squared take away A squared, which is 1 take away 1/2 squared. 1, which I'm writing as 4/4, take away 1/4 is 3/4. Take the square root of both sides. That gives me the square root of 3 over the square root of 4, which is 2. Root 3 over 2 is this length. That's root 3 over 2. So if I make my coordinates here, we know that this length is the x, which is root 3 over 2, and this length is the y length, which is 1/2. We're also told that the cosine of an angle is adjacent over the hypotenuse. I didn't write hypotenuse, I just wrote 1 because our hypotenuse is 1. This is translate to cosine. We'll see why this is going to be the cosine and this is going to be the sine. Cosine of pi over 6 is the adjacent, which is root 3 over 2, over 1 is root 3 over 2. Root 3 over 2 is our cosine of pi over 6. Our sine of pi over 6 is the opposite over the hypotenuse, which is 1/2 over 1, which is 1/2. This guy is our cosine of the angle, and this is our sine of the angle. And we can see that the cosine of pi over 6 is root 3 over 2. The sine of pi over 6 is 1/2. Let's have a look at 45 degrees over pi over 4. Pi over 4 is here. Our radius is 1. We need to find this height. Because this is a 90-degree triangle, and pi over 4 is 45 degrees, right? So if this is 45 degrees, then 90 take away 45 is 45. This is 45 as well. That means these two angles are congruent, which means the opposite sides are also congruent. So this length from here to here is the same as this length. I'm going to call this my hypotenuse. This is my opposite side. This is my adjacent side. This is 1. I'm going to call this D for distance, D. And this is D. We know that C squared is equal to A squared plus B squared. This is our C, is 1 squared is equal to D squared plus D squared, which is 2D squared. Divide both sides by 2. I have 1/2 is equal to D squared. Write that as 1/2 as 2/4. When I go to square root it, I don't want to get a root on the denominator. I'm multiplying the top and bottom by 2 to get 2/4. Take the square root of both sides. That gives us the square root of 2 over 4 is equal to D. Take the square root of 2, which is the square root of 2. Square root of 4 is 2. We have root 2 over 2 is D. Right, root 2 over 2 here and root 2 over 2 here. We can get the coordinates of this point is root 2 over 2, root 2 over 2, where this guy, as we showed before, was the same as the cosine of our angle of pi over 4, and this is the sine of pi over 4. The cos of pi over 4, so the cos of this angle, which is pi over 4, is the adjacent over the hypotenuse, which is the adjacent is root 2 over 2 over the hypotenuse over 1 gives us root 2 over 2, which is this. The x coordinate is the cosine of pi over 4. The y coordinate is the sine of pi over 4. Sine of pi over 4 is the opposite over the hypotenuse, is root 2 over 2 over 1, which gives us root 2 over 2. Sine of pi over 4 is root 2 over 2. Let's look at pi over 3. Pi over 3 is 60 degrees. We have a 60, 90, 30 triangle, which we've already seen here when we're looking at pi over 6. This is the hypotenuse. This is the hypotenuse, which is 1. This is the adjacent. This is the opposite. This is our triangle, and if I make this length, this is 1 and this is 1. We know this is 60 degrees, and this is 30, doubled 60 again. Okay, so if this is 60 and this is 60, this angle must be 60. This is 1 and this is 1, meaning this length also has to be 1. That makes this halfway. This is 1/2, this is 1/2. When we're talking about pi over 3, this is the hypotenuse, this is the opposite, this is the adjacent side. We need to know the opposite side. We use Pythagorean theorem. B squared is equal to C squared, take away A squared. C squared is the 1, take away the A squared, which is 1/2. 1 take away 1/2 squared. Square that 1/2, that gives me 1/4. Right, the 1 is 4 over 4, so we have a common denominator. 4 take away 1 is 3. We have B squared is 3/4. Take the square root of both sides. That's going to give me the square root of 3 over the square root of 4, which is 2. We have root 3 over 2 is the length of B, the length of this height. Root 3 over 2. I can say the coordinates of this point, 1/2 and root 3 over 2. 1/2 is the x coordinate. Root 3 over 2 is the y coordinate of this point. The cosine of the angle is the adjacent over the hypotenuse. And that's going to correspond to this term. The x term is the cosine of theta, or the cosine of pi over 3. The adjacent is 1/2 over the hypotenuse over 1. 1/2 divided by 1 is 1/2. This is the cosine of pi over 3. So the cosine of pi over 3 is 1/2. If we're talking about the sine, we're talking about the opposite over the hypotenuse. The sine of pi over 3 is the opposite over hypotenuse for this angle. So the opposite is root 3 over 2 divided by 1, which is root 3 over 2. The sine of pi over 3 is root 3 over 2. The x-coordinate is always cosine of the angle. The y-coordinate is always sine of the angle for the unit circle. If we look at this point, we have 0 or 2 pi or 4 pi or 6 pi. If we're looking at this point, this is 1, and we're not going up or down. This point is 1, 0. This point, you're going up 1. You're not going left or right. It's 0, 1. This point, you're going -1 in the x direction, -1, 0 in the y direction. Here you're going 0 in the x direction, but -1 in the y direction. 0, -1. For the pi over 6, as we saw, it's root 3 over 2, comma, 1/2. Pi over 3, it's 1/2 root 3 over 2. It's the opposite of this. Pi over 4 was root 2 over 2, root 2 over 2, as we saw. From these 3 points, we can get all these other points. We're doing a reflection across the y-axis. The x is going to become negative. It's going to change sign, but the y is going to stay the same. Instead of being root 3 over 2, 1/2, it's going to be negative root 3 over 2, 1/2. Instead of being 1/2 root 3 over 2, it's going to be negative 1/2 root 3 over 2. And this one, instead of being positive root 2 over 2, root 2 over 2, it's going to be negative root 2 over 2, root 2 over 2. If we translate down this way, well, the y's are going to become negative. Both x and y's are going to be negative. Instead of 5 pi over 6 giving us negative root 3 over 2, positive 1/2, it's going to be negative root 3 over 2, negative 1/2. And this one is negative, negative as well. This one's going to be negative, negative as well. Negative 1/2, negative root 3 over 2. This one, instead of being negative root 2 over 2, positive root 2 over 2, it's going to be negative root 2 over 2 and negative root 2 over 2. All these y coordinates become negative when they're down here. This is positive for the x coordinates, negative for the y coordinates. This point, instead of being positive root 3 over 2, 1/2, is a positive root 3 over 2, negative 1/2. This one, instead of being 1/2 positive root 3 over 2, this is going to, as it comes down, become negative root 3 over 2. Positive 1/2, negative root 3 over 2. And finally, this one, instead of being positive root 2 over 2, positive root 2 over 2, is going to be positive root 2 over 2 and negative root 2 over 2. These are all the coordinates for your unit circle that you need to know. The x coordinates are the cosines. The y coordinates are the sines. So if somebody asks you, what's the sine of 5 pi over 6? You go over here, you look at the y, it's 1/2. And that is it for the unit circle. Have a good day.